Okay, so we're going to simplify and classify our answers here. So this first example, notice the operation that's happening. We are just subtracting. So remember, to add and subtract, the variable and the exponent have to be identical, which they are in this problem. So all we do for addition and subtraction is add and subtract the coefficients of the like terms. So positive 8 minus 5, of course, is just 3, and then we're going to keep the x to the third. That is a single term, so it is a monomial. The biggest exponent is 3, so a degree 3 is a cubic. So it's a cubic monomial. And as always, I want to show you, you can check this answer in your calculator. So I took a small number like 2 and substituted it in for x in the original problem. And then I substituted 2 in for the final answer, and you should get the same thing because we aren't really solving anything. We are just simplifying these problems. All right, part B, this time we are multiplying. You don't have to have the same variable and exponent when you multiply, but we do here. So we're going to multiply this just like we've always multiplied numbers and variables. So you multiply the two coefficients. 8 times 5 is 40. And then when you multiply variables, think back to section 4.1, you add the exponents. So x to the third times x to the third, we're adding those two exponents to get an answer of 40x to the 6th power. And then letter C, I put this here on purpose. This one cannot simplify. Again, it cannot simplify. We have the same variable, but one of those is an x to the second, and one of those is an x to the first. We forgot to do this in the last one, but the last one is a degree 6, because the biggest exponent is 6. I think that is called a sextic, and it is a single term, so it is a monomial. Letter C cannot simplify, but it has two terms. So it is a binomial. There's 1, there's 2. The biggest exponent is that 2, so it is a quadratic binomial. Letter D, we are multiplying. So when you multiply, you do not have to have the same exponent. So we're going to multiply the numbers. 2 times 3 is 6, and x to the second times x to the first. Remember, when we multiply, we just add the exponents, so this is going to be 6x to the third. That is a cubic, because the biggest exponent is 3, and it is a monomial, because there is a single term in this problem. All right, so let's look at a couple of addition-subtraction problems that have multiple terms each. Let's start with subtraction, which tends to be the more difficult type problem. So we're taking a trinomial and subtracting another trinomial. So when we have a subtraction sign in front of the parentheses like we do here, that means we are subtracting everything on the inside of the parentheses. So what I like to do here first is to distribute that negative, or we can say that -1, to each one of these terms first. Doing this is going to make it a lot less likely that you make a mistake. So basically, when we distribute a negative symbol, it makes the original sign of everything on the inside the opposite. So that negative 3x to the fourth is now a positive 3x to the fourth. That positive 2x squared is now a negative 2x squared. And that negative 7 is now a positive 7. And it's only because of this subtraction sign out front. And now we're just going to add our like terms. positive 2x to the fourth and positive 3x to the fourth. We just add the coefficients. So 2 plus 3 is 5, and you keep the variable and the exponent. The next biggest exponent I see in this problem is a negative 2x squared. I don't see any other x squareds in this problem. So that means there's not a like term with negative 2x squared. So I'm going to bring it down. Same thing with negative 3x. There are no like terms with negative 3x. It's got to be the exact same variable and exponent. And then positive 2 and positive 7 add up together to give you 9. And that is a quartic. Biggest exponent is 4. And there are 4 terms, so it's a polynomial of 4 terms. Addition is more straightforward, because if we are just adding everything, really all we're doing is distributing a positive 1. And we know if we multiply everything by a positive 1, nothing really changes. So in this case, you don't even really need the parentheses. So you can drop the parentheses and then just add like terms. Again, always start with the biggest degree first. So I see a negative x to the fifth, but I don't see any other x to the fifths in this problem. So that means there's no like terms with negative x to the fifth. The next biggest exponent, there's no x to the fourth, but I do see a couple of x to the thirds. So we're going to add 7 and 16 together, and that gives us 23, x to the third. I see a couple of just regular x's, negative 6x plus 3x. Negative 6 plus 3 is negative 3. And then there's that lonely negative 7 at the end. There's no like terms with that negative 7. So that's our answer. That is a quintic. We didn't really talk about that one, but the biggest exponent is 5. And it is a poly of 4 terms. Go and pause the video and try the next 2 year turns on your own. So there's the answer to number 1, quintic polynomial of 5 terms. And the answer to number 2. So that's what I got on number 2. Notice the x terms, the negative x plus x, those canceled out. Cannot guarantee I have not made a mistake in there. So double check my work. If you find a mistake, please let me know. All right, so finally, and maybe the most important thing in this entire unit is multiplication. So we're going to multiply a trinomial times a binomial here in the first example. But basically, this just means we're doing the distributive property multiple times here. So what I'm going to do is I'm going to distribute from left to right. So I'm going to take this first term, 5x to the fourth, and first multiply it and distribute it to that second parenthesis. So 5x to the fourth times 2x is 10x to the fifth, and 5x to the fourth times negative 3 is negative 15x to the fourth. So we multiply the coefficients, and then we add the exponents of the variables. All right, so then I'm going to do 5x to the fourth and multiply it by, nope, that's not what I'm going to do. I just did that. So now I'm going to take negative 2x to the third, and I'm going to distribute it to both those terms. So negative 2x to the third times 2x is negative 4x to the fourth, and negative 2x to the third times negative 3 is positive 6x to the third. And then finally, I'm going to distribute that negative 1. So that becomes negative 2x plus 3. And then you just need to find your like terms and add those together from there. And there's what I got. So here were 2 like terms in the middle. And I think that's it. And then letter H, last one and maybe the most missed question. Remember, when you square something, squaring something means you're multiplying it by itself. So when you see a trinomial or any polynomial squared, you need to rewrite the problem because you can't just square each individual term. But instead, we need to write out the trinomial and multiply the trinomial times its exact self. And now you're just going to follow the steps of distribution. So you're going to start with the first term and distribute it to those three terms. So there's what I got for the first step. And then I'm going to distribute the negative 3x to the same three terms. You multiply the big numbers and you add the exponents. And then one more time, distribute the positive 1. Of course, anything times 1 is just itself. So there's a big old long polynomial. No different really than the last one, except for that first initial step, because they wrote the problem a little bit differently. So now you just need to find your like terms and add them together. And there's your answer. And again, notice we have the answer written from the biggest exponent to the smallest. Always put it in standard form. All right, go and pause the video and try that last one, and I'll give you the answer here in just a few seconds. So that's what the problem should look like after the multiplication, and then just add your like terms and classify. And there's your final answer.